All right, welcome back. Today's entire objective is to look at the nitrogen cycle in all of its detail. We're going to look at 3 cycles in this unit in succession: the nitrogen cycle, the carbon cycle, and the water cycle. All of these 3 cycles are interactions among the atmosphere and, at the very least, the Earth's surface. But in the first 2 cases, the nitrogen and the carbon cycle, it's the atmosphere, the Earth's surface, and living organisms through which this cycle carries. Okay, so remember from early on in the course, Earth Science, we split up biota and abiota, or biotic and abiotic factors. Biotic is referring to living, or material that was produced by living organisms and the organisms themselves. And abiotic, the environment that includes nothing living, like the rocks and the temperature and water, rainfall, humidity, weather, climate. So 2 of the cycles, nitrogen and carbon, deal with a lot of the biotic factors, and the water cycle can carry on in its entirety without ever having any biotic or living component. Okay, so today, as promised, nitrogen cycle only. Got about a 15 or 20 minute tops nitrogen cycle lecture. Okay, so if you are at your PowerPoint presentation, on the slide just after nitrogen, where I had explained in our conclusion of our previous lecture that nitrogen is essential to make up the tissues of organisms, both plant and animal. Nitrogen is the primary molecular component of proteins, which is the primary component of living tissue. And nitrogen gets into these living tissues by being fixed to other molecules so that they can be assimilated into systems by the nitrogen-fixing bacteria. Okay? Pretty sciencey, but pretty straightforward. Okay, so we'll advance the slide, and this next slide is a picture. It's entitled Nitrogen Cycle, and it's a pretty good visual of a nice cross-section of the surface of the Earth. You can see a volcano erupting in the background, a nice grassy prairie area with some trees and shrubs on the surface, and a cutaway of underneath where there is soil, where you can see the roots of those plants. And you can see some decomposing skeletons. On the surface, you have what appears to be an elk, a large herbivore. And this pretty picture happens to be by the seaside, and you could tell it's the seaside because there's a big shark underneath what appears to be water there. And you got a big thunderhead cloud, flashing lightning, and all sorts of different nitrogenous components labeled. I'd like you to take notice of the surface of the water has that film of nitrogen-fixing bacteria on it. Nitrogen-fixing bacteria, as I alluded to in the previous lecture, lives in soil as well as in the photic zone or lit surfaces of lakes, rivers, streams, ponds, and the ocean. So the stuff's everywhere, right? Bacteria is everywhere, and as we know now, most of it's really good. It's not make you sick bacteria. It's not pathogenic bacteria. So this nitrogen-fixing bacteria, the major link between the abiotic, atmospheric, gaseous components and the biotic, living organisms, algae, plants, seaweed, shrubs, trees, and the organisms that live off of those, herbivores, and the organisms that live off of those organisms, carnivores, they all get their nitrogen by way of ingesting a organism lower on that food pyramid, closer to the origin of the nitrogen-fixing bacteria, okay? And so organisms, nitrogen-fixing bacteria, literally absorbs nitrogen out of the atmosphere, just like plants absorb carbon dioxide and animals absorb oxygen. Nitrogen-fixing bacteria absorb nitrogen, okay? Different organisms require different resources. All right. So the nitrogen-fixing bacteria fixes atmospheric N2 to oxygen. Nitrogen-fixing bacteria connect nitrogen N2 to oxygen and hydrogen. So we'll get some new, bigger molecules created as byproducts that then can be absorbed into plant tissues. So the primary source of nitrogen is the atmosphere. The nitrogen-fixing bacteria takes it out of the atmosphere and converts it into something more usable by organisms of greater complexity. Organisms like this elk eat plants. And the plants have absorbed the byproduct of the nitrogen-fixing bacteria and assimilated them into their plant tissue. The elk then comes along and eats the plant. That elk now is assimilating the plant tissue into the elk tissue through digestion and metabolism. And then, you know, elks or deer or any other mammal eats and drinks, and then they expel the waste products by breathing out, urinating, and defecating. And we know that, you ever go by a field, drive by a farm, and even though there's no animals there, it's like a freshly planted or freshly plowed field. It stinks like poop. Why is that? Poop. What do farmers use manure for? I think you all got it. Fertilizer. Fertilizer. What does fertilizer do? Fertilizer increases the efficiency of plant growth. A farmer can get a far greater yield of corn in a field that they have fertilized with manure than they would if they just used the natural mineral soil that exists in their farm. So, part of the nitrogen cycle is the elimination, animal waste, pee and poop, and fertilizer. Primary component of fertilizer, whether it be organic, natural manure, or chemical, is nitrogen. You got NPK, nitrogen, phosphorus, and potassium. N, nitrogen, P, phosphorus, K, potassium. Those are your three major macromolecules used for fertilizer. So animals pee and poop in the soil, and that creates a more nutritious environment for plants. Plants literally eat poop. Super gross. Glad I'm not a plant. Right? We know plants photosynthesize to make their own food, but they require certain resources in order to do that efficiently. And one of those resources is nitrogen. Add more nitrogen to the soil, get greater plant growth. So you can see in this picture, the elk is peeing and or pooping, and that is adding nitrogen that it absorbed by eating plants taking from the environment. They used some of that nitrogen in their protein synthesis, and the abundance that they took in includes waste products, nitrogen and hydrogen, ammonia, that they put out. If you ever smell cat pee, and you get a stray cat running around, you're outside spraying, marking its territory, it's got that ammonia smell. That's animal urine, a high concentration of nitrogen and hydrogen, NH3, ammonia. Okay, so part of the nitrogen cycle involves the absorption and the elimination of different ratios of nitrogen linked to other molecules. All right. Decomposition is also another component of the nitrogen cycle. We're looking at when an organism breaks down, decomposes after it's dead. Plant material dies and breaks down, decomposes, makes a nice compost, a high nutrient-rich soil. Bacteria breaks down or is part of the decomposition process, and some fungi act to break apart the large molecules of plant material and return them back to the topsoil. Plant material decomposes and animal material decomposes. Something dies, and over a short period of time breaks down, ashes to ashes, dust to dust kind of thing, breaks down back to the environment, back to the original components from which it was made. Pretty cool. All right, so let's advance the slide to the list of the steps of the nitrogen cycle. I advanced the slide. It now says nitrogen cycle on the top like the last one, but there's no picture. It's a bulleted list of 6 bullets. These are the order of stages of the nitrogen cycle. Starts in the atmosphere, gets absorbed by nitrogen-fixing bacteria. Plants then use that byproduct that the nitrogen-fixing bacteria gave off. Then animals ingest the plants. They absorb whatever materials the plants had synthesized. Then animals pee and poop, or defecate and urinate, releasing ammonia back into the environment. And they decompose post-mortem once they die. They break down. And if you've ever smelled, an organism that's dead, something that's been on the road for 2 days, it's decomposing, stinks. All of these decomposition processes give off waste products that are naturally repelling to our system. We don't like to be around dead, rotting stuff. It stinks. It has no beneficial purpose to us as people, directly,